OR 312, Blizzard Day 1 of 2, Lesson 22. Note, Ross uses VI in their notation, not QI. So if you're reading Ross, if you're reading your textbook, which you should be, VI is the sum of the instantaneous transition rates. Okay, so that's the sum of all of the transition rates out of state I. So if you see a VI, it's there instead of a QI. Okay, so like I said, QIJs are your instantaneous transition rates. And we already talked about how your transition probabilities are just the probability of going from state I to some other state J divided by the total, or excuse me, the rate of going from state I to J divided by the total transition rate out of I. Okay, so now we're going to start talking about steady state probabilities. We can't use the same P matrix and the same method that we did with discrete time Markov chains because we don't have a discrete time increment. So if you think about it, PII, the probability of going from state I to state I in a very small interval is going to be tiny, and in a bigger time interval is going to be bigger or different depending on the transition rate. So because that's not constant through time, you can't use the same method. So instead, we're going to use a different set of balance equations. So for steady state transitions, we're going to use the Q matrix, the transition rate matrix. Number one, your Markov chain still has to be irreducible. This does not work for multiple classes, all right? And the equations are going to look like this. We're still going to use the pi j's, the limiting probabilities. So the probability that you're in state pi, or state j, but now it's going to be state j times qj, so your total transition rate out of state j, and that's going to be equal to the sum across all of the other states of the limiting probabilities for those states times the transition rates from state I to state j. So the transition rates in from those states. So this is for a state j. And the way that, and don't forget, total probability across all the i's. So, and this is going to be for all states. So, there are our balance equations. So how does that work? You think about this like out, the total rate out equals the total rate in. Okay, and you're going to go across the rows of Q for out, kind of like we did for discrete time Markov chains. And the columns, down the columns, for in. Sorry about the phone writing. It's a little hard to do this and hold the paper down. Okay, so we're going to go down the columns for the inside. Ryan's going after more cereal. Spaz. All right.
My tooth came out.
His tooth came out. All right. He yanked it. So, equations are going to look like this. So, let's go back, in fact, to our jet wash example. So we had 3 states. And we have dirty jets arriving with rate mu. And they're getting cleaned up, sent back out, and we're going to stick with our 2-state version like that. Okay, and to get our Q matrix, remember we don't do the diagonals first, we do the other ones first. So the transitions out of state 0, that we're going to have 0 to 1 with rate lambda, 0 to 2 doesn't happen, so this has to be minus lambda. For state 1, we go from 1 to 0 with rate mu. This is going to be rate lambda, so this is going to be minus mu, whoops, mu plus lambda, and this is going to be a 0, 2 mu, 0. So there's our matrix. So now we're going to apply the balance equations. So it's going to look like this. So kind of like we did with the discrete time Markov chains, we're going to start by going across. So this is our out. So we're going out of state 0. So we start off with pi naught q naught, and that's going to be equal to, let's see, well, we're not going to include this one, because remember, we don't, it's only for the states other than, actually this should be not equal to j. It's going to be the states other than the one that we're starting in. So we're going to start with state 1, and we're going to go pi 1 times q 0, 1, and this is 0, so we're not going to worry about that one. Now for the second, now we're going to, that's our in, so now we're going to go out of state 1, so that's going to be pi 1 q 1, and that's going to be equal to, let's see, pi naught, and that's just q 1 0. We skip this and we go plus pi 2 q 1 2. So far so good. And now we're going to go pi 2 q 2, third row, out of 2 into, we have a 0 for pi naught, and then we have pi 1 times q 2 1. And then actually that's not a 0, that's a minus 2 mu. Okay, so those are our equations. So, oh, what am I missing? Total probability, right? Pi naught plus pi 1 plus pi 2 equals 1. Okay, now, yes, we can solve these by hand. And I did this, and I have the algebra to prove it. So, here we go. There's the algebra to prove it. Never mind, pardon the scratched out stuff and the blunt pencil, but I worked through it by hand and came up with probabilities, limiting probabilities down here. Or there's an easier way to do this using matrix algebra. So now we'll do that in the next video.